You are welcome to Math Demystified.
I want to explain the trigonometrical ratios, which are sine, cosine, and tangent. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. Then I want to show you something quickly. This is starting with S, and you have O here, you have H here, and that will be S, O, H. Then this one is starting with C, you have A, then H again, and that is C, A, H. Then here we have T, O, and A, and you have T, O, A. So we can abbreviate all this as SOHCAHTOA, meaning sine equals opposite of hypotenuse, cosine equals adjacent of hypotenuse, tan equals opposite over adjacent. That will help you to be able to reproduce the formula without wasting your time. Now, we call it trigonometrical ratio. The word ratio there simply means fractions, and that's why we have fractions everywhere. We all know how to identify the hypotenuse, the side facing the 90 degree. So I'll show us how to identify the opposite and the adjacent. If I have a right angle triangle drawn anyhow, so say this is a right angle triangle, you can only talk of the trig ratios, meaning you can talk of sine, cosine, and tangent when you have any other angle apart from the 90 degree. Say in this place, I call this one angle theta. And let's label this ABC. And let's also label this one BCA. Now, I want to identify the opposite adjacent before we move on to applying the trig ratio. To this theta, the side joining the angle theta to 90 degree is the adjacent. The side joining the angle to 90 degree is the adjacent. In this case, this is the angle I'm looking for. This is the side joining it to 90 degree. So this is the adjacent. So the adjacent to this angle. The side facing the 90 degree is the hypotenuse. So definitely this one is the opposite. So if I'm to fix this now, my sine theta will be equal to what? So this is my hypotenuse in this case. So that will be C over B. And my cos theta will be SCA, that is adjacent over hypotenuse B. And my tan theta will be what? Good. Will be C over A, because opposite over adjacent, and that is what it will be. So let me clean this, because when I fix the other angle, all this will be different except the hypotenuse. If I come over here and I call this beta, how did I define adjacent? The side joining the angle you are dealing with to 90 degree is adjacent. So in this case, this is the line. So here becomes my adjacent. If it is the adjacent, definitely this is the opposite. The one facing this is the hypotenuse. That one does not change. So let's fix the same thing I just fixed here. Let me fix it here. So we have sine beta, we have cos beta, and we have tan beta, where sine beta is opposite over hypotenuse, that is A over B, and cos beta will be C over B, and tan beta will be A over C. look at this properly because we are moving to something else very soon. Good. I want you to see something right here. If this is 90, and I call this theta, this one that I call beta should be 90 minus theta. Please check very well. If this is 90, sum of angles in a triangle is supposed to be 180. So this 90, it means this plus this is 90. So what do you think this will be? That will be 90 minus whatever this is. Beta plus theta equals 90. Beta equals 90 minus theta. That's what I'm saying. So I can decide to replace beta with this. If I do that, I will have sine 90 minus theta equals A over B. Please take note of all this. Cos 90 minus theta will be equal to C over B. Then tan 90 minus theta will be equal to A over C. Now, let me show us something. Look at this. Look at this. And look at this. You see that they are the same? Have you seen it? That sine theta here and cos beta here are the same. That means that sine theta and cos 90 minus theta are the same. So let me write that. Sine theta equals cos 90 minus theta. Take note of this. Now let's look at this again and compare it with this. You will see that cos theta and sine beta, which happens to be this, are the same. When I say they are the same, what I'm saying is cos theta is A over B, sine theta is A over B. The other one was sine theta was C over B, cos beta C over B. That's what I meant. So cos theta equals A over B. So sine theta equals sine beta equals A over B, and we have said this is the same thing as this. So I can now replace it again and write cos theta equals sine 90 minus theta. This is something you don't want to forget. You don't want to forget it because it's very, very useful. Now there's something again I want to show us. Look at this. Look at this. If you look at this very well, you will see that sine theta over cos theta will give me this. I will show you in a moment. Sine theta, I've said that tan theta is equal to sine theta over cos theta. If you do it, this one is C over B. C over B. Let's change this division to times. That means we'll somersault the lower one, the denominator. Denominator is A over B, so I'll write B over A. If I do, the B will cancel the B, and my answer will be C over A. And that is what this tan theta is. So tan theta is sine theta over cos theta. You don't want to forget this one too. Let me show us another one again. If I have sine square theta plus cos square theta, I will get 1. Let's see if it is true. This sine square theta that you have, sine square theta, means sine theta everything squared like this. But we like to write it like this. So when you see this, it means it's If I write cube here, it means sine everything you have cube. That's what it means. So what I have right here is sine square theta, and this is sine theta. It means I'm going to square this. When I do, I will have c square over b square plus, same thing here, a square over b square. Let's keep working and see if we get 1. This will be equal to the LCM here is what? Is b square. When I do, I'll have c square plus b square. Sorry, c square plus a square. I'll have c square plus a square. So if you look at c square plus a square, let's go back to the diagram and see what c square plus a square is. If I'm looking for this b, I'll put b square. I'll say it's equal to a square plus c square. If you remember your Pythagoras theorem. So, and what you have here is what you have in the numerator here. So that means this is b square over b square. So the answer is 1. So you don't forget this one again. So take note of all of this because you will need them very soon. Okay, I want to show us something else. Now, look at this. Cotangent, which we call cot. We also have secant, you popularly write as sec, and we also have cosecant, often called cosec. Now, how do you easily remember the trig ratio for all of this? You look at this and look at this. Look at this first letter and the third letter, the first letter and the third letter. So when you're looking for cot, cot is 1 over tan. Sec is 1 over cos. And cosec is 1 over sine. So cot theta equal to 1 over tan theta. If you remember what I just said now. And if I do that, let's break it down. 1 over tan theta from here, can you remember? Tan is c over a. So this is a over c. Sec theta is equal to 1 over cos theta, and that's 1 over, what is cos theta here? If you remember, that's adjacent over hypotenuse, and that will be a over b, which will give you b over a. Then the last one, cosec theta is 1 over sine theta, which happens to be, what is sine theta? Sine theta in this case is c over b, and that will give you b over c. Take note of all that. So how do you remember your cot? Just look at 1, 2, 3. 1 over tan. Your sec, 1, 2, 3. 1 over cos. Your cosec, 1, 2, 3. 1 over sine. And that will help you to be able to identify it.
If you enjoyed our teaching, please click like and feel free to share our link with your friends, and do not forget to subscribe to our channel so that you can get notifications of our subsequent videos.